Hi, Michael. It's Professor Sebastian. I got a little carried away because I forgot I can only do 15-minute videos with my free version of Screencast-O-Matic. So it cut me off, and I'm not quite sure where it cut me off. I was going over problem 14 when I looked down to see how much time was left, and it was already cut me off. So I'm not sure how far I got through there because it's publishing that video right now. But I want to finish this. So let me talk about 14 again. We want the first and second derivative of y with respect to x when I'm given this equation. So when I don't and use implicit differentiation, I'm not going to solve for y. So I take the derivative with respect to x on both sides. And you had this mostly correct, except you forgot the chain rule on this part, right? So it's 6/7 y to the minus 1/7, but y is an unknown function of x, so times the derivative of y, dy dx. Then I can just do algebra and simplify this equation for dy dx. Once I have that, the second derivative is the derivative of the first derivative. So now I have to use a chain rule on this. Minus 1/7 y over x to the minus 6/7 times the derivative of y over x, which is a quotient rule. Low d high, x dy dx minus high d low, y times 1 divided by low squared. Then I take my dy dx and I plug it back in here for where I have a dy dx because I know what dy dx is. Then I can make sure all of my exponents in the y's and the x's are correct by just simplifying. So that's problem 14. Okay, problem 15 is another implicit differentiation problem, which it looks like you started off correctly here. So we take the derivative with respect to x of the entire equation, and I get 18y squared times dy dx plus 28x cubed, very good, equals 5 dy dx plus 8. Yes, perfect. Now solve for dy dx. So you didn't solve for dy dx yet. So put every term with the dy dx in it on the left side. So that's dy dx times 18y squared. Bring over the minus 5. So minus 5 dy dx. Factor out the dy dx. Bring everything that doesn't have dy dx in it to the right side. So there's my 8 still there. Subtract 28x cubed. I get minus 28x cubed. Divide by the 18y squared minus 5, and there's dy dx. Then you evaluate it at the point 1, 1 to get actually what the slope is, because the slope is the derivative, right, at that point. All right, 16 you had correct on your own. 17. So y is given this function of x. So what's dy? Well, it's f prime of x dx. So we just have to find the derivative of the function. Well, that's a function times a function. So we have to use the product rule, right? So product rule says, well, how do I use the product rule? So it's first times the derivative of the second plus the second times the derivative of the first. So to do the derivative of the second one, I need a chain rule. 1/2 times the inside, 6 minus x squared to the minus 1/2, times the derivative of that inside, which is minus 2x. And then the derivative of 3x is just 3. And then I just have to simplify this, and there's my derivative. 18, so you got the diameter correct, area. So the area is pi r squared, but the radius is d over 2. So that's pi over 4 d squared. Now I didn't see any work on that diameter problem, and you really need the answer to the diameter problem to plug it in here. So since I didn't see work, I really couldn't increase your score here. Unfortunately, you got the diameter part right. I'm not sure how you did it, but you got it right. So the derivative of a with respect to t is this, right? Take the derivative of this side, so I need a chain rule because d changes with t. So bring the 2 down, so pi over 2 d times dd dt. So we know that pi over 2, we were told d is 12 in the problem statement. The dd dt you should have got from the first part. This 0.3183 is 1 over pi. Plug that in. This simplifies to 6. That's how area changes over a year. Okay, 21 and 22, you got correct with my math lab. 23. What about 20? So 20 I didn't talk about. 20. So let's see, you had 20. I don't know. You got some of this right, probably because you just plugged in the endpoints, but there was no work, so I could not increase your score. But how do you do a problem like this? If you're given a function on a closed interval, in other words, where the endpoints are included, You just check the function at the endpoints and at any critical points in that interval. So we have to find critical points in that interval. So you find the derivative, set it equal to 0, and you see that x equals 0 is a critical point in that interval. So you also have to check 0. So f of 0 is minus 9. That's where the absolute minimum would come from, and you got minus 9 somehow, but you didn't tell me the work. Okay, but the absolute maximum then is at the endpoint of 4, because f of 4 is 7 and f of minus 3 is 0, so the absolute maximum is 7. All right, 23. 23, so you didn't show me any work here, which means I couldn't increase the score. But if you know that the derivative of a function is 2x, that means the function itself had to be x squared, right? Because the derivative of x squared is 2x. Or you add any constant to it, right? Because any derivative of any constant is 0. So really the function is x squared plus c. I just don't know what c is unless I have other information. So in each part they give you other information. They say f of 0 is 0. Well, if f of 0 is just c. But they tell you that's 0, so that means that c is 0. So then what is f of minus 2? You just plug in minus 2 where the c is 0 and you get 4. Then they tell you in part B f of 5 is 24. So if f of 5 is 24, well, f of 5 is 25 plus c. And if that equals 24, that means c has to be minus 1. So f of minus 2 is what they want. So f of minus 2 is, again, minus 2 squared, which is 4, but then minus 1 because of c. So you get 3. And the similar thing in part C, they tell you f of minus 4 is 17. So f of minus 4 would be 16 plus c equals 17, so c equals 1. So now what's f of minus 2? Well, that's 4 plus 1 is 5. So that's 23. 24, looks like you had right on your own, so 25. So 25 says, hey, you're given these critical points, and I want to take these critical points and figure out, I want to take this derivative and in part A find the critical points. So for critical points, you know that we take the derivative, we set it equal to 0, which means that x equals 3, or it does not exist at x equals 0. So there's two different critical points, right? Because you have to consider where either the derivative is 0 or it doesn't exist. Then I'm going to do my first derivative test here. So x and f prime of x. So I plug in my critical points, 0 and 3. I know the derivative does not exist there, and the derivative is 0 at 3. I have to check the derivative in intervals outside the critical points. So to the left of 0, I'm going to check minus 1. I get that the derivative is positive, which means the function is increasing. Between 0 and 3, I'll use 1. I get the derivative is negative, so which means the function is decreasing. And after 3, I'll use 4. I get positive, so that means the function is increasing. That means I have a local max at x equals 0 and a local min at x equals 3. And I know the functions that the intervals that it's increasing on, minus infinity to 0 and 3 to infinity, and it's decreasing on 0 to 3. All right. Based on your answers, I did feel like I could increase something there. All right, 27. Similar type problem, except this is just understanding the sine and the cosine functions really more than anything. So sine of 11x. Well, first of all, sine of x we know is periodic from 0 to 2 pi. It looks like this wave function from 0 to 2 pi. Well, sine of 11x then would look like the same wave function, but from 0 to 2 pi over 11. And that's what they tell you, to go from 2 pi over 11. So the period of 11x is 2 pi over 11. So half of 2 pi over 11 is pi over 11. Half of that's pi over 22, so this guy's 3 pi over 22, and you can see when you graph the sine function there that you have a local max at pi over 22 and at 2 pi over 11, and you have a local min at 0 and at 3 pi over 22. Okay, then what's its derivative? Well, the derivative of sine of 11x is 11 cosine of 11x. So, and we know that the cosine, so it's going to look just like the cosine function on the same period there from 0 to 2 pi over 11. It's just going to have an amplitude of 11. It's going to be higher amplitude. So that matches up with graph D. And then part A, the third part of this is just understanding as you move from left to right what the derivative does. So as moving from left to right, the derivative changes from positive to negative, and then from negative to positive. So we're talking about A here. Okay? All right, and then 28, last one to talk about. Okay, so we're going to find extreme points and inflection points of this function. So first of all, we have to take its derivative and set it equal to 0. That tells us we have two critical points, one at -2 and 2. I have to run the first derivative test like I just did in question 27. I'm sorry, in question 25. So on the first derivative test, I have to check away from the critical points what's going on. Okay, I didn't even write me checking them because it was easy for me to check. So let's say I plug in -3 here, I get -1 times negative, so that becomes positive, so it's a positive over here. Let's plug in 0, I get 2 times, that's -4, so this is negative here, and then let's plug in 3, I get positive, this is positive. So it tells me I'm increasing here and decreasing here, which means I have a local max. I'm increasing to decreasing, and then I'm decreasing to increasing, means I have a local mid. So there's those guys. Then the inflection points, well, possible inflection points are where the second derivative is 0. So I set the second derivative equal to 0. See, though x equals 0 is a possible inflection point. I don't know if it is until I check the second derivative test. To the left of x equals 0, the second derivative is negative. To the right of x equals 0, the second derivative is positive. So that means I go from concave down to concave up. So I do change concavity. That tells me x equals 0 is an inflection point. Okay, so we've gone over the exam, the whole exam. You have feedback from both exam 1 and exam 2. Just get yourself ready for the final exam and ask me any questions you need to ask, Michael. We'll get you through this, and let's try really hard to get you up to that B- at least if we can. All right, talk to you later.